All right, as we begin our chapter 12 on trigonometry, what is the most basic right triangle theorem that you can think of? What is the most popular thing that we know about right triangles? Pythagorean theorem, absolutely. It's a fan favorite. Everybody loves it. Pythagorean theorem. What is Pythagorean theorem? Beautiful. A squared plus B squared is equal to C squared. Now, do any of those pieces, raise your hand, does any of those pieces have any special thing that we need to think about with it? Any special things that we need to think about? A squared, B squared, C squared. Nothing? When we look at our right triangle, is there anything special that I need to be thinking about? I can just slap them wherever I want? All right, that's right. The C is the hypotenuse. The C has got to be the side across from the right angle. Okay, now, what about the other two sides? Does it matter? No. The A and the B can switch around, but either case, does anybody remember the math word to describe those sides, A and B? They are legs. Very nice. So this is a leg in my triangle, and this is a leg in my triangle. And hopefully we remember that when we're thinking about A squared plus B squared equals C squared, we're really thinking about one leg of our triangle squared plus the second leg of our triangle squared equal to the hypotenuse in that triangle squared. The leg squared plus the leg squared is equal to the hypotenuse squared. All right. Now, as we continue on, last year in geometry, you should have spent quite a bit of time talking about something called SOHCAHTOA. What does SOHCAHTOA remind us of? Sine, cosine, and tangent. It reminds us about sine, cosine, and tangent. Now, you'll notice that in this triangle, I've written here an angle which looks like a zero with a line through it. It looks like this. That is the angle theta. Theta is just a fancy letter. It's a fancy letter in the Greek alphabet. I could have put X there, I could have put Y there, but I decided, and most often when we're doing trigonometry, we're going to decide to put the angle theta there. It's just a fancy way to write it. We look important. Looks impressive. Okay? But it's no different than an X or a Y being there. Angle theta, I could have called it angle T. All right? Now, as I think about SOHCAHTOA, we'll remember that we're going to be talking about sine, and the abbreviation for sine is SIN. Now, as I'm finding the sine of that angle theta, notice I write SIN of theta. The angle needs to be there. Don't just write SIN. You've got to put the sine SIN of the angle theta. Does anybody remember how to find the sine? Oh, yep, we're going to be using our calculator quite a bit today. But what is that ratio? Absolutely. Looking at this SOH. SOH reminds us that sine is opposite over the hypotenuse. Sine is the opposite over the hypotenuse. Now, just a question. Up here on my triangle, then, I need to be thinking about these pieces. If I'm going to be doing sine is opposite over hypotenuse, where would I find those pieces? All right, my C has to be the side across from the right angle. So across from my right angle, I know that this side is going to be the hypotenuse. I love it. What about opposite? Where do I find the side opposite of theta? All right, either leg, does it matter? Maybe. Does it matter? Nope, I can pick opposite right here? No. Is this opposite of theta? No. Opposite means across from. Is this across from theta? I don't think so. So I'm going to go from theta and I'm going to go across. I'm going to go to the opposite side, and this is the side opposite of theta. Does anybody remember what we call this third side? The adjacent side. It's the side that's attached to that angle, but it's not the hypotenuse. It's the side that's attached to that angle that is not the hypotenuse. Okay, so sine, we find opposite over hypotenuse. Beautiful. All right, what about cosine? How do I find cosine? Adjacent over the hypotenuse. Remember SOHCAHTOA? The CAH reminds us of cosine being adjacent over hypotenuse. So the cosine of my angle theta, COS of my angle theta, is going to be adjacent over the hypotenuse. Beautiful. And what about tangent? All right. Tangent, the abbreviation is TAN of my angle theta, is opposite over the adjacent side. Okay, now, last year in geometry, I'm sure you spent quite a bit of time talking about sine, cosine, and tangent. But there was a secret that they did not tell you last year in geometry. And that secret is this. Sine, cosine, and tangent are not the only ones out there. There are actually three more. There are actually three more that are buddies with sine, cosine, and tangent. Okay? If we are looking for something that is a buddy to sine, buddies with sine is cosecant. Sine and cosecant are buddies. They're not friends with anybody else. Sine and cosecant are buddies. They are not buddies with anybody else. They're only friends with each other. It's an exclusive little club. All right? Sine and cosecant are friends with each other. The abbreviation for cosecant is CSC of my angle theta. Now, in order to find the cosecant, I will find the hypotenuse over the opposite. In order to find the cosecant, I'm going to find the hypotenuse over the opposite. So why is he friends with sine? Yeah, it's the reciprocal. Very nice. We will get to that in a couple days. When I start doing sine with the -1 power, that means I'm doing the inverse. And we're going to get there. Yes, that's very different. That's great to bring up. That the button in your calculator that's sine to the -1 power, that is not what we're doing here. That actually helps me find the angles, and we will get there. We will get there. But right now we're just going to focus on sine, which is opposite over hypotenuse, and his buddy, cosecant, which you're not going to find a button on your calculator for cosecant. They're not on there. Cosecant is hypotenuse over opposite. So I heard somebody say, well, they're friends. They have a relationship because they are reciprocals. If I take the sine and I flip it over, I get the cosecant. So the cosecant is the reciprocal. It's 1 over the sine of my angle theta. Okay. Now, cosine. Cosine is buddies with secant. Cosine is buddies with secant. Secant is abbreviated SEC of theta. If I want to find the secant of an angle, I will do the hypotenuse over the adjacent. So once again, why are they friends? They are reciprocals. If I have the cosine, I can flip it over to find the secant. So the secant is 1 over the cosine of my angle theta. And last but not least, this one I think makes the most sense for people. This is the one that people don't forget as often. Tangent is buddies with cotangent. That seems to make more sense to people. Tangent and his buddy cotangent. The abbreviation for cotangent is COT of my angle theta. How do you anticipate we would find the cotangent? Absolutely. We find the tangent by doing opposite over adjacent. So my cotangent is going to be the adjacent over the opposite. Because the cotangent is the reciprocal, it is 1 over the tangent of theta. Now, Like I said, it seems like people get this one. Oh yeah, tangent and his buddy cotangent. Okay? But these two sometimes we mix up. For some reason, people want to say, well, cosine should be buddies with cosecant. That's not the way it is. Sine is buddies with cosecant, and cosine is buddies with secant. Sometimes that gets people messed up a little bit, so make sure you keep that straight. Sine is buddies with cosecant, cosine is buddies with secant. Okay? All right, any questions with that? All right, let's flip to number 2 there. Flipping to the next page there, looking at number 2. All right, evaluate the 6 trig functions of theta shown there in the right triangle. All right, when they're talking about evaluating, finding the 6 trig functions of theta, what are the 6 trig functions? What are the 6 trig functions? What? Yep, tell me what they are. Okay, so we're going to be finding the sine of the angle theta. What else are we going to be finding? The cosine of the angle theta. What else are we going to be finding? Tangent of my angle theta. And then, who is buddies with sine? Cosecant. So if I'm finding the sine, I'm going to find the cosecant of theta. Who is buddies with cosine? The secant of theta. And who's buddies with tangent? Cotangent of theta. All right, so, all right, I'm getting ready for this. I'm excited. The sine of theta. All right, Jack, how do I find the sine?
It's the opposite.
All right, the sine is the opposite over the hypotenuse. I love it. The sine is the opposite over the hypotenuse. So I look at my triangle. I haven't even focused on that yet. I look at my triangle here and I see that this is the angle theta. All right, do I know what is opposite of that angle theta? All right, I go from theta and I go straight across. Theta straight across, that's 7 is the side opposite. Over, what about the hypotenuse in this triangle? What? How do you know? All right, I need to use Pythagorean theorem. I do not have the hypotenuse yet. I do not have the hypotenuse, so I'm going to use Pythagorean theorem. Now, when I write down Pythagorean theorem, a squared plus b squared is equal to c squared. A squared plus b squared is equal to c squared. The a, the b, and the c, do any of them have to be anywhere special? All right, which one's got to go somewhere, William? Where does he need to go? Yep. Where does he need to be in the picture? Does he have a special place in the picture? Yep, he's going to be the longest side, which is across from that right angle. So from that right angle, I go right across and I call it C. Do the other 2 sides matter? No. Nope, the A and the B are both legs. We can swap them around as we need to. The C is the one that has a special location. It has to be the hypotenuse. So we've got A squared, which is 24 squared, plus my B squared, which is 7 squared, is equal to that C squared, which I don't know. All right, getting out your calculators very quickly. Getting out your calculators. Going to be using them quite a bit today. All right. All right, what's 24 squared? Nike, you got that? 24 squared? 576. Plus, that's all right, Nick, that's all right. What about 7 squared? 49 is equal to C squared. All right, Miss Leo, what do I get then for C squared? Yep. 625, that's a big side. That's a big side. Are we sure we're right about that? Oh, that's right, that's C squared, right? So to undo the squared, I'm going to square root both sides. So C is equal to, what do I need to remember when I square root both sides? Plus or minus. What's the square root of 625? Plus or minus 25. But what do we know? Yeah, we can't have a negative side. So C just has to be a positive 25. C just has to be a positive 25. So that means this side of C is going to be 25. Oh, that looks good. Okay, so now, got to go back to why I needed that. Gotta know why I need that. So sine is opposite, which is 7, over my hypotenuse, which is 25. Okay. All right. How do I find cosine? Miss Morgan, how do I find cosine? Adjacent over hypotenuse. Okay. So when I'm sitting at this angle theta, what side is adjacent to that angle theta? All right, which one's attached to it, but not the hypotenuse? The 24. The 24 is definitely the adjacent side. Over, what's the hypotenuse? The 25, yep. All right, can't reduce that fraction, but we know if we could, we definitely would. Always reducing any fraction we possibly can. Okay, so tangent. Tangent. How am I going to find the tangent there, Shia? Beautiful. Tangent is always the opposite over the adjacent. All right. Shia, what is opposite of my angle theta? 7 over what's adjacent? 24. And can I reduce that fraction? No, but if I could, I know I would. All right, going back to cosecant. Cosecant. Matt, who's he buddies with? Who is cosecant buddies with? Sine. Okay, so if cosecant is buddies with sine, and I know that the sine is 7 over 25, what will the cosecant be? Beautiful. It's the reciprocal. 25 over 7. Or I could say, you know what? Cosecant's always hypotenuse over adjacent. Well, the hypotenuse is 25 over the side, hypotenuse over opposite, which is hypotenuse is 25, the opposite side is 7. I wrote it wrong, I apologize. Okay, let's take a look at secant. All right, Natasha, who is secant buddies with? Cosine, absolutely. So if the cosine of my angle theta is 24 over 25, what will the secant be?
25.
Beautiful, 25 over 24. Once again, remember it's hypotenuse over adjacent. And last but not least, Tyler, what will our cotangent be?
24 over 7.
Beautiful. Cotangent is buddies with tangent, so if tangent is 7 over 24, the cotangent will be 24 over 7. Fantastic. So far, so good? All right. Let's take a look at number 3 now. Taking a look at number 3. We have, if theta is an acute angle. Oh, he's cute. Is that what they mean by that? He's a cute angle. That really wouldn't be fair. They're all cute. What do they mean by that? Less than 90. All right. In a right triangle. Well, that's right. Because in a right triangle, the other two angles have to be less than 90 in order to be able to add up to 180. So that means that this angle would be our angle theta. All right. And the cosine of theta is 3 over 8. Okay, let's see what we know about that. The cosine of theta is 3 over 8. Okay, let's think about that for a minute. How do we find cosine? Adjacent over hypotenuse. That's right. The cosine is the adjacent over the hypotenuse. Okay, so if my cosine is 3 over 8, and if my cosine is adjacent over hypotenuse, what do I know? Yeah, how much is that adjacent side? 3. Where do I put that on here? Yep, which side's the adjacent side according to my angle theta there? The bottom, absolutely. The bottom side is attached to that angle theta, but it is not the hypotenuse. So this is my adjacent side, which I know is going to be 3. How much is my hypotenuse going to be? 8. My hypotenuse will be 8. And where do we find that? All right, go from my right angle straight across to find my hypotenuse, which is going to be 8. Okay, now I didn't even get to the problem yet. I have no idea if what I'm doing is anything remotely close to what I should be doing. It wants to know what is the value of cosecant of theta. Okay, so what they want me to find is the cosecant of theta. Any thoughts about anything we know about cosecant? That's right, it's the reciprocal of what? The sine. Cosecant is buddies with sine. That's all I remember. Cosecant is buddies with sine. Now, how do I find the sine? Opposite over hypotenuse. Okay, so the sine of my angle theta is equal to, what is opposite? Oh yeah. Do I know the side opposite? No, it's right here. But can I find the side opposite? You bet. What can I use? You bet. I'm going to use Pythagorean theorem. Pythagorean theorem. A squared plus B squared equals C squared. Now, what is my A? All right, my A is going to be the 3. It's going to be one of the legs. Plus, what's my B? Oh, the B is the opposite side that I don't know. Equal to, what is my C? My C is always the hypotenuse, so that's 8 squared. Loving it. All right, everybody's working hard. Go ahead, find B. Very quickly, find B. Finding B. Oh my gosh. Oh, that's almost like a dagger. Almost like a dagger, Nick. All right, tell me what you're doing there. What'd you do there, Nick? Walk me through this. Yep, what's 3 squared? 9 plus B squared equals, what's 8 squared? 64. Okay, then what'd you do? Yep, you subtracted 9. So B squared is equal to? 55. Okay. Then what? Square root both sides. I love it. So B is equal to? Oh my gosh. It's that pain again. Do we like decimals? Is the square root of 55 nice? No. Now I got a question. Can I make the square root of 55 nicer? What are the factors of 55? 5 and 11. What do we know about them? They're prime. Can I do anything with the square root of 55? So what do I write? Square root of 55. Do we ever want decimals? No, no, no. That just breaks my heart. Don't ever want decimals. We love to simplify radicals. If we can reduce a fraction, we always do. If we can simplify a radical, we always do. This one I can't simplify. It's kind of sad. But I know that this side for little b is the square root of 55. Doesn't that feel better, Nick? Yes, I thought so. I thought so myself. All right, so the sine. How do I find sine again? Curtis, how do you find sine? Opposite over hypotenuse. Beautiful. So that angle theta, what's opposite of that angle theta? Square root of 55 over, what's my hypotenuse? 8. Okay. Now, is that what I was looking for? No. Ultimately, what do I want? What am I ultimately looking to find, folks? The cosecant, okay? And the cosecant has what relationship with the sine? No. Nope, nope, nope. Reciprocal. Don't say opposite because then we think negatives are thrown in there, right? reciprocal. We're going to flip that fraction. So if sine is the root of 55 over 8, that means cosecant is 8 over the root of 55. Now, can I leave it like that? What am I going to do with that? Yep, I got to rationalize that denominator by multiplying the top and the bottom by the square root of 55. So the cosecant of theta is equal to, well, 8 times the square root of 55 is 8 square roots of 55 all over. What's the square root of 55 times the square root of 55? 55. Yep. Square root of 4 times square root of 4 is 4. Square root of 16 times square root of 16 is 16. Square root of 55 times square root of 55 is 55. Are we okay with that? Are we okay with that? Okay, let's take a look at number 4. Number 4 is a good one. What does it tell us we are supposed to do in number 4? Solve for x. Okay, so we're solving for x. Now, what is this x? He's the hypotenuse. I love it. Thanks, Will. All right, he's the hypotenuse. He's across from that right angle. Now, what angle do they give me? 42. They give me this angle of 42. And what other information do they give me? The 5. What is 5? The opposite of 42. That's very nice. If I go from 42 and I go across, the side opposite of 42 is going to be 5. Okay, now, I know opposite, and I'm looking for hypotenuse. Which trig function is this begging for us to use? Sine. Beautiful. Sine uses opposite and hypotenuse. The sine of the angle theta is equal to opposite over hypotenuse. Okay, so sine of my angle theta. How much is my angle? 42, absolutely. Is equal to, what is opposite of that 42? 5 over, how much is the hypotenuse? X. Very nice. We don't know. That's the x. Okay, now, does anybody have a thought on what we would want to do to solve this? Nick?
It's 42 and 90, so that'd be 48. And then something like the outside has 3 sides. And 360 or something.
Ooh. Ooh, ooh. Yeah, that's okay. That's okay. 360, we're thinking circles. 360, we're thinking circles.
360.
Yep. Yep. I got it. How am I going to get x by itself? That's ultimately what we're looking at. Just this little equation here. What is in the denominator of my fraction? X, right? So what am I going to multiply on both sides? X. Whatever's in the denominator of my fraction, folks, is what I want to multiply on both sides. So I have x multiplied by the sine of 42 equal to, my x's are going to cancel here, and we get 5. All right, now what would I do to get x by itself? Beautiful. We're going to divide both sides by the sine of 42. All right, so my sines of 42 cancel, and x is equal to, I've got no choice. Got to grab that machine. That's as good as we're going to get, and yes, it's going to be an ugly decimal, but we can't do any better than that. So we're going to take 5, and we're going to divide it by the sine of 42. Do that very quickly. The sine divided, 5 divided by the sine of 42.
7.5.
Will, what'd you get?
Or do you just want 7.5?
I want it to the 100th. We're working hard. 7.47. Does everybody agree with 7.47? Anybody didn't get 7.47? There might be something messed up on your machine.
Is anybody getting negative? I think I corrected them. They're almost all pretty. That's
All right. So here we go. Now let's take a look at number 5. How do the instructions in number 5 change? What does it say? Solve the triangle. Okay, here they just told us to solve for x. But here they're telling us to solve for the triangle. Does anybody know how that's different?
Does that mean
Oh, no. When it says solve the triangle. Beautiful. We need to find all of the sides and all of the angles. We're not finding just one thing anymore. We're finding everything in that triangle. We're not finding just one thing anymore. We're finding everything in that triangle. Okay, so let's take a look here at number 5. It's a good one. All right, taking a look here at number 5. What do they give me? I always start by looking at, okay, what do they tell me to get started? Yep, they tell me 2 angles. This angle's 62, and this angle is 90. I like that. All right, then they tell me the 6. Now, if I'm looking at this 62 angle, what is 6 to that angle of 62? Adjacent, okay? This would be adjacent to that 6. All right, now, hopefully we remember from geometry. Hopefully we remember from geometry that when we're trying to give things names around here, when I get triangle ABC, and I'm trying to name the things in my triangle, if I'm at triangle ABC, we always say, well, from angle A, I go straight across and I call this side little a. From angle B, I go straight across and I call this side little b. And from angle C, I go straight across and I call that side angle C. Hopefully we remember that from geometry last year, the way we name our triangle so we keep everything organized. Okay, now, I know that little a is 6, and I know that the 6 is the adjacent side to this 62. Okay, what things am I missing? What things am I missing right now in my triangle? I'm missing angle A, and I heard somebody say we're missing little b and little c. Okay, are there anything that I can find? Angle A. I should be able to find the measure of angle A. And how would I do that? All right. All 3 of these angles need to add up to 180, right? Or if this is 90, those 2 are complementary and add up to 90 also. So that means that 90 subtract 62 means that that angle is 28 degrees. Absolutely. And we can double check. 28 plus 62 plus 90 is definitely 180. Okay. Now, if I'm looking at little b, if I'm looking here at little b is what to that angle at 62 that they gave me? Opposite. Okay? Now, if I want to find opposite and they told me the adjacent, what trig function am I thinking about using? Tangent. Because we know that the tangent of the angle theta is equal to opposite over adjacent. Okay, so tangent of the angle theta. Do I know the angle? How much? 62. Is equal to, do I know the side opposite? What am I going to call it? I'm going to call it little b. Over, do I know the side adjacent? 6. All right, now if I'm solving and I want to get little b by itself, what am I going to do to get little b by itself? Multiply both sides by 6. So I'm going to take 6 times the tangent of 62 to get little b. So about how much is little b? Calculator's as good as we can get. We don't have any other options. 6 times the tangent of 62. 11.28. We okay with that? All right. Now, let's take a look. All right, so I know this side is 11.28. Is there anything I don't know yet? I don't know little c. Now, what is little c in this triangle? The hypotenuse. It's across from the right angle, so it is the hypotenuse. Okay, now I remind myself, I'm looking for the hypotenuse, and what side did they give me? They gave me the adjacent. Which trig function do I know that I want to use if I'm involving hypotenuse and adjacent? cosine. Absolutely, because we know that the cosine of my angle theta is always adjacent over the hypotenuse. Okay, so cosine of my angle theta. Do I know what the angle is? 62 is equal to, all right, the adjacent side. What are we calling that adjacent side? It's 6, absolutely. We know that the adjacent side is 6 over, what about that hypotenuse? Little c. All right, anybody got a thought on what the first thing we want to do to solve here is? You bet. In the denominator of this fraction, I have a little c, so I'm going to multiply both sides by little c. So I have little c times the cosine of 62 is equal to, my c's are going to cancel, and I get 6. All right, Brandon, what are you thinking we should do next? Ultimately, what am I trying to do? Find c, which means I want to get c by itself. So what's over here with c? Cosine of 62. So how am I going to get rid of the cosine of 62? Okay, wait a minute. What's going on between c and the cosine? You bet. They're multiplying, so I'm going to divide both sides by the cosine of 62. So my cosine of 62s are going to cancel. Little c is equal to, all right, no choice. Using that machine, what's 6 divided by the cosine of 62? About 12.78. So this last side, the hypotenuse, is about 12.78. I know that I'm done because I know every angle and I know every side. Absolutely. Matt's got another idea. He says, wait a minute, couldn't we use a squared plus b squared equals c squared to find c? Yeah. Should I get the same thing? Absolutely. Completely another way that is completely a legitimate way to find c also. Any other questions? Great question. Thank you for bringing up that point. All right.